imaginary numbers were developed or created, you could say, to assist us in finding square roots of negative values. So, for example, this square root of negative 49, if it were just the square root of 49, we could do it. But the negative that's in there prevents us from just saying, okay, well, this is the same thing as the square root of 49. So mathematicians came up with a symbol to represent the square root of a negative, and the symbol that they came up with is I. So here's how this works. We can rewrite the square root of 49 as the square root of negative 1 times the square root of 49. That way, the negative is removed, and only the negative is removed, but we still have the value of the number, and we can take the square root of that. So the square root of negative 1 is defined as I, and the square root of 49 is 7. Remember, we're looking at the positive roots. So the way that I would write this would be 7i. So the square root of negative 49 is equal to 7i. All right, so I is what we're going to use to represent the square root of negative 1. And vice versa. When you see the square root of negative 1, you're going to replace it with an I. All right, so let's try that over here. That means that negative 80 can be rewritten as the square root of negative 1 times the square root of 80. Right? We can pull the negative 1 out. We know that this part is I, but now we need to do the square root of 80. We need to simplify this radical. And you may have done this in Algebra 1, so this may just be a refresher, but we can use factor trees to simplify this radical. So over here on the right, I'm going to do a factor tree for 80. And I know that 80 can be broken up into 2 times 40. And I know that 40 is 2 times 20. And I know that 20 is 2 times 10. And 10 is 2 times 5. Every time you have a pair of numbers, then that means that you can take it out of the radical. And here's why. I can now rewrite this, if I wanted to rewrite it all out, as here's my first pair. Here's a pair of 2's. So this would be 2 times 2. I'm going to put 2 squared. And here's another pair, 2 times 2. And then my 5. So we learned in a previous lesson that anytime the index number, which is not written but it is a 2, matches the exponent number, we can pull that value out. So that means I can take this 2 and bring it out in front. I can take this 2 and bring it out in front. And then, unfortunately, the 5 doesn't have an exponent of 2, so the 5 gets left inside. And then I can simplify this further to say 2 times 2 is 4, so 4 root 5. That's what the square root of 80 equals. Now, I didn't have to do this step right here. This step, in my opinion, is unnecessary. So the way that you can skip that step is anytime you have a pair of numbers, you pull it out in front. Here we have another pair of numbers, pull it out in front, and then this has no pair, so it gets left inside. Right? That's the method we're going to use when we're simplifying radicals. Now, if you know your perfect squares, and if you know them well, then you know that 80 is 16 times 5. If you know that, then this whole thing becomes a lot quicker, because then you know right away that 80 is the square root of 16, which is 4, times root 5. If you know your perfect squares, you are more than welcome to jump to that. If you can rewrite it as a perfect square times another number, go ahead and do it. Jump to it. If not, if you don't know all of your perfect squares, I recommend learning them because it will make your work a lot easier when simplifying radicals. But you can always do this method of the factor tree. And with the factor tree, anytime you have a pair, it comes out in front. You have another pair, comes out in front. And then whatever doesn't have a pair gets left inside. All right, so let's finish this problem because we're not done yet. So we know that this part, the square root of -1 is I. Hold on, there we go. We know that the square root of -1 is I. And we know that the square root of 80 is 4 radical 5. So now we've got to put them together. And the way that you write them together is the number comes first, the real number comes first, then the imaginary number, and then the radical. So that's the order of things here. Real number, imaginary number, and then your radical. All right, so that would be our answer. So I is just the square root of -1.